Hey, good morning. Yeah, our talk is Trust, Track, and Verify, Securing AI Pipeline End-to-End. I'm an independent consultant from Tampa, Florida. Spent 17 years at Oracle, and since been independent for 3 years. I'm a generalist. This is my first KubeCon or any open source security conference. Really glad to be here.
Hi, my name is Adolfo Garcia, or Puerco. I'm working on a startup I created this year called Carabiner Systems. I maintain a bunch of the technical initiatives in OpenSF. I also work on the Kubernetes release engineering team.
So everybody's talking about AI, and everybody's talking about AI governance. The problem is AI governance means different things to different people. But one thing is clear. AI security is top priority in any AI governance discussions. That's why I said I'm a generalist. I go to different places. This is another organization I participate in called CoSAI, which stands for Coalition for Secure AI. There's a lot of familiar names like Ernst Young, Google, IBM, Microsoft, NVIDIA, as well as model providers such as Cohere, Anthropic, and OpenAI. There are 4 work streams at CoSAI. That's AI security risk governance, how to defend against AI security threats, supply chain security, as well as defending against securing agentic AI systems. So this is what's been working on. So it's more AI governance. You know, corporate governance. This is AI governance. This is still work in progress. Can change in the future. So what we at this point think there are 3 layers of responsibility when it comes to AI governance. So if you are corporate, we start with like if you're a board member and you work with your governance team and management team to look at what's the use cases for AI, right? You have the business driver, you know, the business use cases, and you basically define the objective and goals for AI governance. For that, we call it user layer. Then after that, your management team and governance team work together to implement your AI infrastructure, security, et cetera, to make sure that's what typically AI governance is about. That we call the core layer of security, AI governance. And finally, any company, no matter which company you are, you have something that not developed by yourself. For example, Kubernetes, you know, AI models not trained by your company. Because of that, that's a foundational technologies that's external to your company. Because it's for that, we call it foundational layer. Yeah, so this is user layer, core layer, and foundational layer. And then for each component, each layer, we say there are 4 components: system, policies, rules, and practices. There's, so if you're familiar with cloud, public cloud, there's a so-called shared responsibility model for public cloud providers. Similarly, we're defining a shared responsibility model for AI governance. That's still also work in progress. So once you have the object and goals, the AI governance model, then you start to look at the actual activities, right? So at this point, this is one of the publications called Established Risk and Controls for the AI Supply Chain. In here, we have defined that there are several mitigations that's needed. One is using SBOM. The other one is model signing. So that's what we're going to talk about today. Throughout the lifecycle of an AI model, from the time the model is trained till it's fine-tuned and then eventually deployed in production, AI BOM or AI SBOM, it means the same thing. Together with model signing, allow you to track your AI pipeline end-to-end and provide the security you need to secure the AI pipeline. And this is the SPDX, which is the ISO standard for SBOM. It's a graph language. Using it, you can create knowledge graphs. There are other well-known knowledge graphs in the security industry, such as MITRE ATT&CK, MITRE DEFEND, MITRE ATLAS, OpenVex. Together, you use this knowledge graph to create your own knowledge graph internally, and which can be saved in the JSON LD, which stands for JavaScript Object Notation, and it's W3C standard. SPDX has been in production since 2010. At first, it was just for licensing, and eventually by 2021, it became an ISO standard, and it's used across industry all over the world. This year, we see a lot of new profiles and new changes to the SPDX SBOM. In particular, I want to bring your attention to two of them. One is supply chain. In the past, when you have individual like software AI model, they're individual supply chains. But in the real world, they all depend on each other, right? Data is used to train the model. Software is where it's foundation where model and data is processed and created and processed. Because of that, supply chain profile has been introduced to make it really multidimensional. But by the way, it's linked data, remember that keyword. Another profile that was added is threat control. With knowledge graph, we actually tested it out. I actually gave one of the Kubernetes threat model, give to the Meta guys. They were able to create a knowledge graph with this internal tool automatically, a threat model automatically. With threat control profile, you'll be able to integrate those kind of knowledge, threat models and those knowledge graphs with SPDX to give you a full visibility into the full lifecycle, AI lifecycle. So if anything to take away about SPDX, which stands for System Package Data Exchange, it's a graph language with integrated ontology for universal data capture and sharing. In the past, when you generate an SBOM, it's a point-in-time capture. Over time, it becomes stale and outdated. Now, with SPDX 3.1, you'll be able to dynamically generate SBOM, especially hardware SBOM, and then integrate with other SBOM, like AI, data, software, et cetera, to be able to do something we call universal data analysis. Imagine two businesses. Well, it can be different company or same company, two organizations. When they talk to each other, if they use the same SPDX graph ontology language, you can create a common knowledge graph automatically. That enables what's called dynamic data capturing and sharing, including supply chains such as AI, datasets, hardware, software, operation, threats, cryptography, security, licensing, and functional design. So the two businesses in the last slide, it can play any role in the supply chain. It can be the manufacturer, supplier, service provider, but as long as they talk in the same language, SPDX is easier for automated integration. But as long as a knowledge graph, the integration is possible. So that's SPDX. Now about model signing. So model signing is trying to answer questions such as who trained the model, right? Has it been fine-tuned? Has it been tampered with? And can you prove it? So through the life cycle of the AI model, from the data sets to deploying production, along the way, SPDX, AI SBOM, and model signing work together to make sure data is the transparency and security and authenticity can be guaranteed. Ideally, in the future, all claims about metadata, ML models, data sets, and metadata are tamper-proof, and then tied to an identity, and automatically generated by tools commonly used by ML developers. So with that, I'll pass to Adolfo for the demo.
All right, thank you, Victor. Okay, so well, based on those three premises that the CoSAI supply chain working group identified as the initial pressing issues for AI SBOMs, which are checking the integrity and also locking all of its elements down with an AI bill of materials. So we were working on this demo that I'm going to show you. So a little bit of a background story. My family, my daughters, they love pets, maybe too much. We have 8 pets. And this is a story about 4 of them. So we have 2 dogs, Lucho and Cheto. And we have 2 cats, which are Toño and Mingo. They're all regular pets, except Mingo, the last one. She's an evil mastermind. She just won't take it from humans. Every time that you piss her off, she will come and do something nasty to her. So in a house where you have 2 cats and 2 pets, it obviously leads down to the inevitable, which is the spectacular dogs versus cats showdown. And this is what I mean by it. So whenever you go back to your house, you find a mess like this. And it's always like, oh, my house is like completely destroyed. Who did it? And if you had cameras or something, you could determine that and see who's the culprit behind it. But we live in the age of AI, so everything must be AI. So my family developed this cool new application, the Pet Behavior Detective. So what it does is that we have been feeding it different pet behaviors over the years, and now it can detect, through the magic of AI, who did what. So let me show you how it works. So just a disclaimer, I'm going to do this with the models pre-trained, because in this machine, they take like 10 minutes to train, so we don't have that time. So if I do in the terminal, all right, thank you. So the way it works is pretty simple. You go here and then ask it to do, for example, the creature knocks down things in my desk when I'm working, and it'll tell you it's definitely the cats. OK, cool. So revolutionary technology. So let me continue with this. Obviously, we're using the Enterprise Edition at home because we have a big problem, right? So OK, so this is what I was explaining. Like, pets will take it. Like, dogs won't mind when they're being signaled by the tool, but cats, they will not take it. Like, especially her. Like, look at her face, right? So when the cats detected that we were doing this to blame them, she started thinking about a sweet revenge on us and the dogs. So she started looking at how we build the models, right? And so quickly, Mingo identified how we train this thing. And then, so we've been collecting and observing what they do. They train a model on that information, build an API image, and then deploy that to Cloud Build. And that's what we use whenever we need to distribute blame. Based on this information, she started thinking, how do I break this? And the first one is, well, I will poison your data, which means the cat is going to attack the first phase of the inference lifecycle. So to show you, I'm going to close this one. So this is going to build the inference server. And then I'm going to run this. OK, so all right, so if I go back to the model here, so I'm going to restart this. So if I ask it, hopefully this will work. But so it knocks things while it's like working on my desk. And now the model has been altered, and it's distributing blame to the dogs, which is the plants cat. So if I go back here and I check out what's happening inside of the repom, you'll see so the font. Is that big enough? Probably. OK. So if you see what's happening here, when I run the sophisticated build system that trains this model, you'll see that there's a diff here on the data set. And you'll see what's going on. So, oh no, the data set has been patched to blame everything on dogs instead of cats. OK, so how do we protect against this? So in order to protect against this, we hold on, data set. We switch to here. So we have we built data SBOM. So this is an SPDX tree SBOM describing the model. So what it does is that we essentially have, this is an SPDX tree SBOM describing the data set. So it has some of the qualities some of the particular qualities of the data set, and other information, like as Victor mentioned, describing the graph of who did it, how it was trained, and so on. So we can use this model as an attestation of the data set, and then protect and write a policy to protect it. So if you see the build system here, probably you can see the tag of the cat here, but OK. So we're running here a policy to check based on the data. So I'm pulling a policy that I wrote to check on the model, and then it just, for now, it's just verifying the very first layer. So does it have an SBOM describing that particular data set? These examples are very simple, but you can start digging down the policies on the SBOM contents itself. So when you run it, if I run the the build script again. So the policy breaks because it doesn't find the SBOM describing the dataset. So this is tying the hash of the dataset with the expected attestation. All right, so let me go back to the presentation here. So when the dogs notice that, we need to protect against the model data poisoning, and so that's what we did. So this is what we did. So in the first stage, we created an SPDX SBOM with the hashes and the properties of the dataset, then wrote a policy, gated around that, and then the training now blocks because we have the policy. Now, since those attacks were thwarted, we move on to the next phase. And then since the cat managed to train the model on the poison dataset, then it'll attack the next phase of the life cycle, which is the training process. So if I switch here let me reset this. So I will do the build again and serve. So the model training script is now protected with a policy protecting the data. But if I come here and I try to run the same cat behavior again, it's still blaming the cats. So why? And then you can see here, if I check the build script, I see that the models are now modified. So this means that the cat managed to train the model on the original data, but then replace the model with the one trained on the poison data. So how do we train and protect against that? Now, let me try seeing if we can make this work, because I was having a little bit of problems yesterday. So what we need to do is, so how do we protect, let me switch back to this one. So once the dogs notice that there's another problem with the model, what do we need to do? So we need to protect building the inference image that's serving the results with another policy that checks the integrity of the model. So what we're going to do with this one is we're going to sign it with the OpenSF model signing. It's a one of the Sixer projects. So model signing, what it does is that it essentially grabs some of the files in the model and generates a hash describing them, and then generates a manifest that you can sign and to protect the model. So let me reset the branch. This and 2, 4. Okay. So let's see if I can model signing. Sixer. Model signing, sign. So it's asking me for my Sixer credentials. Okay, so now it's signed. All right, so if I now run the build here, now it fails. So why did it fail? I can show you. So because now we have the model signature. So if we look at the script, you'll see that we are now protecting the script with another policy that checks for the signature of the model. So don't pay attention to this little thing here, because it's a hack I had to do to extract the model, the SHAs of the model. But essentially what it's doing is that it's looking at the model that we're trying to serve, grabbing the model signatures, checking that it passes, and since they don't, it gates on the build and blocks it. All right, so back to the presentation. One sec. Sorry, I lost my window. All right. Hold on, where's my?
Yeah, Adolfo is amazing. He created it in a very short time.
Yeah. So hold on, because this is a draft. Okay. So this is where we are, like blocking here. So essentially what we did is protect the first two layers of the inference model. Now this is super simple. The policies are only checking the signatures and not going deeper. And because there's all sorts of things that you can start building on top of that. Like, for example, you can start locking the weights and the hyperparameters on the model based on the data from the AIS BOM. You can also start checking for specific files to be included in the model manifest. As you saw in the policies, we're not checking the signer identities as well. So there's lots of things that you can start building on top of it. But this is kind of the first two phases of locking down the model. So this essentially restores justice and distributes blame equally to cats and dogs. And yeah, so.
Thank you, Adolfo. Yeah, so so first I talk about CoSAI, where because AI governance is where a lot of the corporate like SEC actually, for example, is really think is even the board member need to know AI governance well. So we start with the business driver, use cases, and how to realize business value. And then we go through the solution recommended. This is just two of the solutions. The other solutions that's going to be discussed in the future. So by using what Adolfo just showed, the model signing and AI BOM, you'll be able to really secure your AI pipeline end to end. So for SPDX, if you're interested in joining the community, let me know. There's a Slack workspace you can join. SPDX 3.1 is going to be released pretty soon. Thank you.
And finally, I wanted to share like the demo that you just saw is completely open source. It's you can find the policy engine, and these are the links to the model transparency and the SPDX3 spec that we were using to do the demo. And yeah, that's it.
Thank you.